Stephanie from Design Plus Code. In this 11th section of the SwiftUI Concurrency course, we will implement swipe gestures so that we can pin some sections at the top of our list. To do so, we'll need to update our section model and add the new swipe actions modifier to our section list. So let's dive right in. Let's open our Xcode project and click on our section model. We'll update the section model by adding a isPin variable to each section. So we'll do var isPinned, which is of type Boolean, and we'll set it by default to false. This variable will let us filter the sections array so that the pinned sections can go on top of the list. Now let's go to the section list. In here, we will update our for each loop. With SwiftUI 3.0, we can pass a binding value to the loop and we get a binding variable while looping through the array. This is done by adding a $sign in front of the array we're looping through and adding another one in the section that we get when we're looping through this array. By adding a binding variable here, it lets us update each element in the array, so we can modify the isPin variable within this view. You can see that we have an error here that says the property section setter is inaccessible. If we go to the section view model, we added a private set to the sections variable so that we can only set this variable within this class. Since we want to update the sections in our section list, we need to remove this here. And this fixes the error. Next, we'll need to add swipe actions to each text in our for each loop. But first, let's take a look at the documentation. You can see that swipe actions is new because it's only available in iOS 15 and plus. And swipe actions have three parameters: an edge, an allows full swipe, and a content. The edge parameter can either be trailing or leading depending on which direction you want the swipe gesture to be. The default is trailing, meaning swiping to the left. The allows full swipe indicates that when the user swipes to the edge, the action is automatically performed. Let's take a look at an example here. So if I swipe completely to the edge of the list here, you can see that my section is now pinned to the top. The default to this variable is true. And finally, we have some content, which is usually a button. If we scroll down in the documentation, we can see an example code here. So we have a message cell, and you have two swipe actions to this message cell. The first swipe action is to mark the message as read or unread, and it's when we're swiping to the right. We also have some swipe actions to the left with two buttons. The first one is to delete the message, and the second one is to flag the message. In our case, we will add our swipe actions to our text. So we'll do .swipe actions. We will omit the edge and the allows full swipe values because we will use the default values since we want the swipe gesture to be trailing and the allows full swipe to be true. Inside of the swipe actions, the only parameter that we need to provide is the content inside of this closure here. So we'll be adding a button. So you can see that the button has two closures. The first one contains the action and the second one is the label. For the action, we will take the section .isPin value and toggle it. We will add two labels depending on the value of isPinned. So if section.isPinned, we will display a label for unpinning the section and we'll provide a system image from SF symbols, which will be pin./ Else, meaning that if the isPin value is false, we will provide a label to pin the section at the top of the list with the system image pin. So let's try to test this code. If I swipe, for example, on the UI Design for Developers item, I have pinned my row because when I swipe again, you can see that the icon here is the pin with a slash on it. If I swipe again on this row, it will unpin the section for me. However, the color here is gray and that doesn't look really nice. So after our swipe actions modifier, we'll add a tint modifier and we'll provide the yellow color. You can take any color that you want. And you can see that now we have a pin with a yellow color here. So let's test out this code again. Let's swipe on a row and it will pin and unpin our sections. However, there's no indication that lets us know if the section is pinned or not, unless we swipe the row and see if it's pinned or not. Let's create a function that orders the section by moving the pinned ones at the top of the list. Let's go to the section view model and we'll create a new function at the bottom of this view. This function will be called order sections by pinned. And the content of this function will be sections.sort. We want to sort by the value of isPinned. So we'll do $0.isPinned and $1.isPinned. This will take a look at all the elements inside of the sections array and take all the sections where isPinned is true and put it at the top of the list. The rest will be at the bottom of the list. Back in section list, right after we toggle the isPin variable, we will call our section view model .orderSections by pin function that we just created. Let's resume our preview and test that again. So I will swipe on the Build a SwiftUI app for iOS row. And you can see that it moved to the top of my list. And this is the same for all the rows that I swiped on. However, we still have one issue. We don't know if the section is pinned or not unless we swipe it and see the unpin button here. So I will wrap my text in an H stack and move the text inside of the H stack. Right after my text, I will add a spacer. And below the spacer, I will check if the section.isPin value is true. If it's true, I will display an image from SF Symbols, which is the pin.fill, and we'll add some foreground color yellow to it. So let's test out this code again. If we swipe on a row, you can see that my section row moved to the top and we see a nice little pin on the right side of our row. Great, we implemented swipe actions to our section list. In the following section, we'll see how to implement a search feature in our application so we can search through this section list. Hi, Stephanie from Design Plus Code. Welcome to section number 12 of the SwiftUI Concurrency course. In this section, we'll take a look at another modifier introduced at WWDC21, which is the searchable modifier. This modifier lets us add a search field on our list and navigation view, and we can also easily add suggested searches with it. In this section, we'll learn how to implement this search feature in our sections view. If we look at Apple's documentation on the new searchable modifier, you can see in the code example here that we are using the searchable modifier on a navigation view. This modifier only works on a navigation view. In content view, we'll wrap our sections view instance in the navigation view. Let's play our preview and go to the sections view. You can see that right now we have a lot of padding on top of the title. So let's go to sections view and we will remove the text we added and use the built-in navigation title instead. On the VStack, we will add the modifier navigation title, and the text will be all sections. Let's go back to content view again and resume the preview. You can see that now we don't have the unwanted padding on top of our title. Next, still in content view, we'll add a state at the top. So at state private var, we'll call this text and we'll set it initially to an empty string. This text state is where we'll save the text the user inputs in the search field. Under navigation view wrapping our sections view, we'll add the new searchable modifier. This modifier takes two parameters, a text, which is a binding string that represents the search value the user inputs, and a placement. The placement is optional because by default it's automatic, meaning that SwiftUI will find the best placement depending on the context and the content of your view. In our case, we'll omit this property because we want to leave it to SwiftUI to place it at the best place it can find. So on our navigation view, we will add the searchable modifier. And we only need to provide a binding string, so we'll do $sign and provide the text state that we created on line 12. Let's resume our preview again and go to the sections view. You can see that SwiftUI added a search field right below our title here. However, now we're met with a little issue. We initialized our section view model as a state object in our section list back when we only needed that view model within this view. Now, since we're adding the search feature in content view, we'll need the section view model in many places. So we'll need to initialize that section view model at the top level in our app file. So we'll do at state object var section view model will be equals to an instance of section view model. And we add the environment object modifier and pass the section view model we created on line 13. Next, we'll need to add this environment object to the content view. So environment object var section view model will be of section view model type. Don't forget to also initialize it for the preview so that our preview works. We'll also need to do the same for our section list. So instead of initializing an instance of section view model here, we'll add the environment object here, section view model, which is of section view model type. Don't forget to fix the preview by adding the environment object and initializing a section view model here as well. The searchable modifier comes with the closure, and we can add some search completion suggestions. So in content view, we will be adding the closure to our searchable modifier, and we'll do a for each loop called the section view model.sections. And we'll do prefix 3 to get the 3 first elements in the sections array. Then we'll display a text, which will be the section.title, and add the search completion modifier to it. You can see that the search completion modifier requires a string, so we'll provide the section.title string. If we click on our sections view and click on our search field here, you can see 3 rows of suggested searches here, which are the 3 first sections from our sections array. Great, we now have the basic layout implemented. But if we search for colors, for example, nothing is happening because we didn't add the functionality yet. We just added the search bar. Let's go to the section view model. At the top, we will create a new variable. It will be a published variable, public private set, and we'll call this variable filtered sections. It will be an array of sections data collections.section model, and we'll initialize it with an empty array. Then at the bottom of our view model, we will create another function called filter sections for text string. So this function will allow us to search through the sections array. The first thing we need to do is to reset our filtered section to an empty array, because we want the filtered section to always be empty when we search through the content. Next, we will do text, which is the text property that we pass to this function, dot lowercase, so that all the text is lowercase and we won't have to deal with uppercase and lowercase letters. Let's save this in a search text variable. Then we will loop through the sections array, so sections for each, and for each section, we will get its title. So we'll do section.title, and we'll save this in a search content variable. Next, we will add an if statement. So if the search content dot lowercase with a range of search text, and we'll also need to pass the options parameter, which is the regular expression. If this isn't equals to nil, then we will run some code. So this line of code checks if we have a section title that matches the search text that the user inputted in the search field. So if there's a match, we will call the filtered sections and append the section that we found a match with. Great, now let's go back to our content view. On the navigation view of the sections view, we will add a new modifier, and this modifier is the onSubmit modifier. On submit of search, we want to perform some action. When the user searches in this field and hits return on their keyboard, we want to call the section view model dot filter sections function for the private text date that we have on line 13. So let's go to our sections view here and test out this feature. So if I search for color and then hit enter, I still see the entire sections array. It's not filtering anything. So that's why we need to go to sections view and update this file. So at the top here, we will add an environment object, var section view model, which will be of section view model type. Don't forget to add it to the preview to make it work again. Then in the body of this sections view, we will add an if statement. So if our sections view model.filtered section.count is higher than 0, then we will display the filtered sections. Else, we will display our sections list here. If our filtered sections array is higher than 0, we will display a list and call the section view model.filtered sections. For each section, we will display a text with the section's title. If we go back to content view and test out our code again, so let's search for colors and hit return on the keyboard, you can see that we have the colors and branding section here. However, when we hit cancel, we don't see our entire array anymore. We want to display the entire sections array when we're exiting the search field. Luckily, SwiftUI has us covered as always. We'll add another variable at the top of the file called isSearching. This is a new environment variable that lets us know if the search field is currently active or not. So back in sections view, we will add a @environment variable, which will be the isSearching variable, var isSearching. IsSearching is a Boolean value that tells if the search field is active or not. So we'll make sure that the isSearching variable is true before displaying our filtered section. Else, meaning that if the filtered sections array is empty, we will display a list of one item with a text that says no results. Let's go back to Content View to test out all of this code that we just added. So if I click on the Sections tab and search for colors and hit return, I can see my colors and branding section. If I hit cancel, I have all these sections that we added to Contentful at the beginning of this course. Nice! So we implemented a search feature in our application using the new searchable modifier. In the next section, we'll go back to our home view. We'll create a button at the top right corner that shows a model when we tap on it. We'll also learn how to manage different models so that users can go from the sign-in model to the sign-up model, for example. So see you in the next section. Hi, Stephanie from Design Plus Code. Welcome to section number 13 of the SwiftUI Concurrency course. In this section, we'll learn how we can display different models on top of our view. We'll create a model manager that handles all the logic related to model management. First, we'll create a profile icon component. So I will right-click my components folder and create a new file. This file will be a SwiftUI view and we will name it profile icon. Since this course and this section don't focus on UI and more on logic, we won't be coding the profile icon together. So you can find the entire content of the profile icon in the text content below or in the completed project in the source files. So you can see that here we have a VStack with an image using the SF symbol person crop circle, and we also have some blur background around the image. And this makes this nice looking profile icon. Now let's go to home view and we'll be adding this profile icon in home view. First, we'll be wrapping our date title in an H tag. So I'll press on Command and on date title and embed this in an H tag. Inside of this H tag, we'll have our date title, a spacer, and then we'll call our profile icon. So you can see that right now our profile icon is really close to the edge of the phone. Let's move the horizontal padding on the date title to our H stack. And now we have some horizontal padding around our date title and profile component. When the user taps on the profile icon, we'll present the sign-in model on top of our view. From the sign-in model, the user can navigate to another model. Let's say to the sign-up model. And we can also navigate to the reset password model and back to the sign-in model. In order to add this feature, we need to add a sign-in, a sign-up, and a reset password model. You can find the entire code of all of these three files inside of the source files of this project. So it's really important that you download the source files. Once you downloaded the source files, go into the code folder and then into the 13th section, Managing Models. In here, you will see the three models that I mentioned before, as well as two components that are used in these models. So we will simply need to drag and drop this into our components folder, and then click on Finish. You can see that we imported a gradient button, a gradient icon, our reset password view, our sign-in view, as well as our sign-up view. Next, we'll need to create our model manager. So under the utils folder, I will right-click and create a new file. This file will be a Swift file, and I will name this file Model Manager. Inside of this file, we'll create a class called Model Manager, which will conform to the observable object protocol so that the entire program will be notified of changes within this class with the help of a publisher. Inside of this class, we'll create an enum. This enum will be called Active Models. We'll have three possible cases inside of this enum. The first case is sign-in, the second case is sign-up, And the last case is reset password. We'll also add two published variables inside of this class. So add published var show model, which will be a boolean, and by default it will be false. So this value will allow us to know if we should show a model or not. The second published variable will be active model, which will be of active models type, and initially we'll set it to the sign-in model. If you remember, in all the view models that we created so far, all the published variables had the public and private set keywords. However, in this case, the show model and the active models will be available everywhere in the application, so we can add the public keyword in front of these two variables. But we will want to set these variables outside of this class, so we don't need to add the private set keyword. Next, we'll need to create our model manager view. So under the views folder, we will create a new file. This file will be a SwiftUI view, and we will name it model manager view. This model view will listen to the active model variable in the model manager and displays the corresponding model. So at the top here, we will add an environment object, var model manager, which will be of model manager type. Don't forget to add the environment object for the preview as well. The body of the model manager view will be a Z-stack. Inside of the Z-stack, the first thing we will add is a rectangle. Z-stack works in 3 dimensions, and the first element that you add is the element that is the most at the bottom of our view. So right now we have a rectangle. Let's change the foreground color to black with some opacity to 0.5. We'll also need to add the modifier edges ignoring safe area.all so that it covers the entire screen. Right after this rectangle, we will create a switch statement. So the switch statement will check the model manager.activeModel, and for each case, we will display the corresponding model. So the switch statement will take care of the sign-in case. In this case, we will display our sign-in view. If the active model is sign up, we will display our sign up view. And finally, if the case is reset password, we will display our reset password view. So you can see that now all the errors are gone and our preview works. Since the default active model that we added in our model manager is sign in, the preview here displays the sign in model. Let's go to content view and we will initialize our model manager in here. So we will add a state object, var model manager will be equals to the model manager with parentheses at the end. Next, we'll need to wrap our entire tab view in a Z-stack. So I will click on comment on my keyboard and then on the tab view and embed this in a Z-stack. Right below my tab view, I will add an if statement. So if my model manager dot show model value is true, then I will call my model manager view that we just created. If we play our preview and tap on the profile icon, nothing happens right now. That's because we didn't add the functionality to toggle the show model value. Let's go to the home view to add this functionality because our profile icon is in home view. So we'll need to add the model manager environment object at the top of this file. Model manager will be of model manager type. As always, remember to add the environment object to the preview as well. Then, on tap gesture of the profile icon, we will call our model manager.showModel, and then we'll call the .toggle function to toggle it to true. Now, let's build our preview in the simulator and test out this code. So I will tap on the profile icon here, and you can see that we run into an error, and it says that no observable object of type model manager found. To fix this, we will need to add the model manager environment object to our home view. So let's go to content view, and on the home view, we will add the environment object modifier and pass the model manager instance that we created in this view. Since we have another view that has the model manager as an environment object, we'll also need to call the environment object modifier to our model view and pass the model manager instance that we created in content view. So let's build our application again and test out our code. If I tap on the profile icon, we see our sign-in view. However, if I tap on the grayed out rectangle below this model, nothing happens. So we can't dismiss this model and we're stuck here. Let's go to our model manager view, and on tap gesture of our rectangle, we will call the model manager model and then toggle the value to toggle it to false. If I build my application in the simulator again and test out this code, you can see that my model is dismissed every time that I click on the background rectangle. However, we have another issue. When I tap on sign up or reset password, nothing happens. The only model that is shown is the sign-in model, and we didn't implement the possibility for the user to switch between different models. So let's go to the sign-in view. Scroll down to the bottom of the view and you can see at the bottom here that we have two links. We have the sign up link and we have the reset password link as well. So let's add the environment object here. Environment object var model manager, which will be of model manager type. Remember to add it to the preview as well. Environment object model manager. Then on tap gesture of the sign up model, we will call our model manager.activeModel and set it to the sign up model. We'll do the same for the reset password link. So on tap gesture, we'll call the model manager.activeModel equals to reset password. Next, we need to do the same for the reset password view as well as the sign up view. So on the reset password view, we'll add the environment object at the top. Model manager will be of model manager type. Don't forget to fix the preview. And on tap gesture of the sign-in text, we'll call model manager.activeModel equals to the sign-in model. We'll do the same for sign up view. So we'll add the environment object at the top. Don't forget to fix the preview. On tap gesture of the reset password, we'll call the model manager.activeModels equals to reset password. On tap gesture of our sign-in link, we'll call model manager.activeModel equals to sign-in. Let's test out this code. So I tap on my profile icon and I can navigate between the models. However, when I dismiss my model and then I come back, it's still the reset password model. I want to reset this model to the sign-in model whenever the user quits this model view. So let's go to the model manager view, and when we are toggling the show model to false, we will reset the model manager.activeModel to the sign-in model. Let's build the application one last time in the simulator and test out this code. So if I tap on the profile icon, I see my sign-in view. I can navigate to sign up to reset password. And if I dismiss the model and come back, you'll see that it has reset to the sign-in view. Great! We now have a model manager in our application that toggles between different models. In the next section, we'll create a new view called Account View. We'll learn how to fetch data from an API using an HTTP GET request and display the data in our view. We'll also review how to turn a function that uses completion handlers into an async await function. This will make our code cleaner and save a lot of lines of code. See you in the next section. Hi, Stephanie from Design Plus Code. In this 14th section of the SwiftUI Concurrency course, we'll review the async await method of creating asynchronous functions. This time, instead of using the Apollo GraphQL SDK, we'll be creating an HTTP GET request using URL session. First, we'll use the old way using completion handlers. Then we'll convert this function into an async await function. We will have to display the data that we fetched in a new view, which is the account view. So in Xcode, we will create a new view. Under the views folder, we will create a new file, and this file will be a SwiftUI view. We'll name this file account view. Since the account view has its own tab in our application, we'll need to go to the content view and add this in our tab view. So we'll call the account view that we just created, and we'll add a tab item. The tab item will have an image and the system name will be person. We'll also add a text that says account. So you can see that right here we have the account tab, and for now we only have the hello world text. We will fix that view later on once we have the data. Before continuing, let's take a look at the API. We'll be using a website called JSON placeholder and calling the user's endpoint. In here, you can see that the users is an array of objects and each object represents a user. In order to better see the JSON format, We can go to Chrome and use a Chrome extension called JSON Formatter. If we don't have this formatter, you'll see the JSON object like this. But if we parse it, you'll see colors, so it's easier to read. So you can see that we have an array of 10 users. If we take a look at the documentation of JSON placeholder, you can see that we can access a specific user by providing the ID in the link. For example, in here, I can add a /1 to get the first user, which is Leanne Graham. That's the endpoint that we'll be calling. In Xcode, we'll need to create a model that follows the structure of the user object that we get from the API. So under the models folder, I will right-click, create a new file. This file will be a Swift file, and we'll call this file the user model file. So the user model will be a structure called user. It will conform to the identifiable protocol as well as the decodable protocol. The identifiable protocol means that each user will have a unique ID, and the decodable protocol means that we can take this JSON object and convert it into this user model in Swift code. Next, we simply need to add all the variables that we see in the JSON object here inside of this model. So the first one will be an ID, which is an integer. Next, we have a name, which is a string, a username, which is also a string, an email. But now we run into an issue. We have an address, which is a JSON object. And inside of this address object, we also have a geo object. So to fix this, we simply need to create another structure inside of the user structure. So we'll do struct address, which will conform to the decodable protocol so that we can convert this JSON into Swift code. And we simply need to add all the variables. So a street, a suite, a city, a zip code, and geo is also a JSON object. So inside of the address structure, we'll create another structure called geo, and it conforms to the decodable protocol. It contains a latitude as well as a longitude. Then we have a phone and a website that we can add right after our email. So phone, which is a string, website, which is also a string. And the company is also a JSON object, so we'll create another structure right below the address structure called company, and it conforms to the decodable protocol. We have a name, a catchphrase, as well as a VS. You can see that we created an address structure as well as a company structure, but we're not using them anywhere. So we need to create a var called address, which will be of address type, and also a company var, which is of company type. Remember to also link the address with a geo. So var geo will be of geo type. You can compare this structure with the structure that you can find in the text content below to make sure that you have all the required fields and that you don't have any typo. Please note that the P of the catchphrase here is a capital P. If you don't add a capital P, you'll run into a decoding error later on. So make sure that everything is the same as the user model that you can find in the text content of this section. Now that we have our user model, we'll create a view model. Inside of that view model, we'll create a function that creates an HTTP request and fetches the data from the API. So I will right-click on my view models folder and create a new file. This file will be a SwiftUI view, and we'll call this file account view model. Inside of this file, we'll create a class called account view model, and it conforms to the observable object protocol. We'll add a function called getUser inside of this class. Next, you can copy and paste the code for the HTTP request in the text content below. This is the old way of creating an HTTP request using completion handlers and data tasks. You can learn more about how this is done in the HTTP request section of the SwiftUI Advanced Handbook. You can access it by going to this link, or you can also find this link in the text content below. So basically, we make sure that we have a URL. Then we're creating a URL request that we pass to this data task, and we can get data, response, and/or an error. If there's an error, we exit the function and print the error. Next, we make sure that we have a response and that the response status code is 200 OK. If everything is OK, we unwrap the optional for the data and then use the JSON decoder to decode the JSON, so to transform the JSON into the user model that we just created. If this succeeds, then we will print the decoded user. You can see that the JSON decoder.decode is marked with the try keyword in front. That means that it might run into an error, and that's why we do a catch statement here to catch the error whenever we run into an error, and it prints the error. Finally, we do data task.resume to resume the task and then exit the function when everything is done. Next, we will go into our account view and initialize the account view model here. So we'll add at state object var account view model will be equals to the account view model with parentheses at the end. Remember to fix the preview by adding the environment object as well. Next, on appear of this view, we will call the getUser function that we just created to see if we do get some data printed on the console. We will be fixing the content of this view later on, so let's just call the onAppear modifier on our text here. So on appear, we will call the account view model.getUser function. Now, let's build our application in the simulator to see if we do have our decoded user printed on the console. Once the app is launched, we will click on the Account tab so that the account view appears on our screen. Then, let's go to Xcode, and we can see that we have our user, Leanne Graham, printed on the console. So everything works. Now, we're ready to turn our function into an async function. First, we will remove everything related to the data tasks, so that we only have 2 lines of code left. The guard statement that makes sure that we have a URL and the URL request that we are creating. Next, we will call the URL session.shared.data for the URL request variable that we created on line 14. So data is a new function that works with asynchronous code. So let's add the try await right in front of this line. Try means that the function can throw an error, and await means that this task can be suspended so that other work can be done on the thread. However, we run into an error. It says async call in a function that does not support concurrency. So to fix this, we will add the async keyword to the getUser function to make this function asynchronous. Next, we have another error that says error thrown from here are not handled, because the data function might throw an error, so that's why we added a try in front. But now Xcode is complaining that if we ever run into an error, there's no way to catch the error. To fix this, we will mark this function as throws. The throws keyword will let the program know that this function can throw errors. Great, we silenced the error, but now we're left with a warning. It says that the result of the data function is unused. This function can return us data and a response. So let's save that in 2 variables called data and response. Now Xcode is telling us that data and response are not used. We'll fix that right away. So first, we will create a guard statement, and the guard statement will make sure that the response is of HTTP URL response type. And we need to add a question mark because this is optional. Then we'll call its status code and make sure that it's 200. 200 means that everything is okay and we can run the next line of code. Else, we will throw a fatal error, and the content of this fatal error will be error while fetching data. Once this is done, we will call the JSON decoder and we'll call its decode function. The decode function takes 2 arguments, a type, into what type of data you want to convert your JSON object, and you want to decode from what data. So for the type, we will call the user.self. And the data that we want is the data variable that we have on line 16. So this function can throw an error. And you can see that Xcode is now telling us that this function can throw an error. Let's add the try keyword in front. And this function also returns some decoded user. So let's save that in a decoded user variable, and then at the end, we will return the decoded user. However, you can see that it says that this function doesn't expect to return anything. So we simply need to add a return statement here and let the program know that this function will return a user. Great! So we turn the getUser function that use completion handlers, which contain about 20 lines of code, into only 7 lines of code here. Async await really saves lots of lines of code. If you build your application now, you run into an error from the account view onAppear modifier. We'll be fixing this in the next section and display the user we fetched in a beautiful profile card. See you in the next section! Hi, Stephanie from Design Plus Code. Welcome to section number 15 of the SwiftUI Concurrency course. In the last section, we successfully fetched the data from the API by creating an HTTP GET request and using the new async await keywords. In this section, we'll call this function to fetch the user's data and display the data in a beautiful profile card. We'll also learn how to open a link in a Safari browser inside of our application. If you build your application now, you'll run into an error, and we mentioned this error at the end of the last section. If you remember in the section fetching data with Apollo, instead of using on up here, we used a new modifier called task. This modifier supports asynchronous code. We also need to add the await keyword since the getUser function is an asynchronous function. And finally, we have one last error that says call can throw, but it's not marked with a try. And also, the error is not handled. So we'll add a try keyword, and to handle the errors, we will wrap everything in a do catch statement. So we'll add do, and then move this function inside of the do statement, then catch, and print the error if we ever run into an error. So error while fetching user. And if you remember, the getUser function returns a user. So that's why we have a warning here that says that the call to getUser is unused. So at the top of this view, we'll create a private state called user, which will be of user type and it will be optional. Then we simply need to save the result of the getUser function in our user private state in this view. Let's try to display the user's name in our view. So we will add a vstack around our text and then wrap our text in a if statement. So if let user equals user, so we need to do this because the user state is optional, so we need to unwrap the optional here. Let's move the text inside of the if statement, and instead of saying hello world, we will display a text that says hello user.name. Let's resume our preview to see if everything works as expected. Right now, the screen is blank because we need to press on the play here so that it fetches the data. You can see that we have hello Leon Graham in our view now. Great! Now let's go in the source file of this course, and under the code folder, we will navigate to the profile card section and add the profile card file into our Xcode project. So I will drag and drop it into my components folder. Then I click on finish. This file contains a profile card already coded for you with hard-coded data. Instead of keeping the hard-coded data, we will add a user property to this card so that it shows the data that we fetch from the API. So we'll do var user will be of user type. So you can see that here we have an error that says missing argument for parameter user in call. To fix this, we need to create a dummy user only for the preview. So you can find this preview data in the text content of this section. Basically, we're creating a user with all the required fields, and we also have the address and the company of this user. We also created a preview address and a preview company because if you remember, the address is of address type and the company is of company type. Finally, we simply need to pass the user property and pass our preview user to this preview. This will silence the error. Next, let's resume our preview and we will be updating the hard-coded data by the data from the user that we passed to this profile card. So instead of name here, we will replace it by user.name. For the description, we will replace by user.company.catchphrase. Instead of hard-coding designcode.io, we will replace it by user.website. Let's go back to account view, and instead of displaying a text that says hello Leon Graham, we will display our profile card. So we'll create a profile card instance here and we'll pass the user state. Let's add some horizontal padding of 8 pixels so that our card doesn't hug the edges of the phone. If there's no user, the screen will be blank. So let's simply add an else statement and display a text that says no user if no user is fetched from the server. Let's go back to the profile card, and right now when we tap on our link here, nothing happens. We could open the link in an external Safari browser, but let's see how we can open it inside of our application. So under the utils folder, I will right-click and create a new file. This file will be a Swift file and we will name it SF Safari View Wrapper. At the top, we need to import SwiftUI as well as Safari services, so we can create a Safari browser inside of our application. Next, we need to create a structure called SF Safari View Wrapper, and it will conform to a UI View Controller representable. We need to pass one argument to this structure, so we will pass a URL. The URL will let Safari know what link to open in Safari. And now you can see that it says the type SF Safari View Wrapper doesn't conform to the protocol UI View Controller representable because it requires us to add two basic functions. So the first one is a MakeUI Controller function. Instead of passing a context of context type, we will be passing a UI View Controller representable context on self. And instead of returning some UI View Controller, it will return an SF Safari View Controller. So inside of this function, we will add a return statement and create a SF Safari View Controller by passing the URL that we passed to this structure. We also need to create a second function, which will be the Update UI View Controller function. We only need to replace the context here. Instead of having a context of context type, it will be a UI View Controller representable context on SF Safari View Wrapper. Inside of this function, we simply need to return. So this will allow us to create a Safari browser inside of our application. Back in Profile Card, we will create a state at the top. This state will be private and we will call it Show Safari. It will be a boolean and by default it will be false because by default we don't want to show Safari. Then let's scroll down and on tab gesture of the H tag which contains our link, we will call the Show Safari and then toggle the value to true. If the Show Safari value is true, we want to present a full screen cover. So on the V stack of our body, we will add a full screen cover modifier and select the one with the is presented. Is presented requires a binding boolean value, so we simply need to add a $sign and then pass the show Safari value. And we don't want to run any code on dismiss, so we can remove this code. And for the content, we will create an instance of SF Safari View Wrapper, and we need to pass a URL to this Safari View Wrapper. So we'll create a URL from a string. And the string will be https:// and then we'll pass the user.website value here. It's important to unwrap this URL because this will create an optional URL. It's also important to add the HTTPS in front because the Safari browser inside of your application only accepts HTTP and HTTPS requests. So let's resume our preview and test this code. I will click on the designcode.io website and you can see that it creates a Safari browser and I can now navigate on the design code website inside of my application. If I click on done, it will simply close the browser. Great, we displayed the data that we fetch from the server in a profile card, and we also learned how to create a Safari browser inside of our application. In the next section, we'll learn about actors, a new reference type introduced at WWDC 21. See you in the next section. Hi, Stephanie from Design Plus Code. In this 16th section of the SwiftUI Concurrency course, we'll explore actors. We'll see why and when this reference type is useful and apply it to a simple example in our application. When we talk about actors, we must first talk about data races. So data races happen when a state is being accessed at the same time by two different tasks, and one of the tasks is trying to write to that state. A data race can be dangerous because it can lead to memory corruption. Let's take the example of a counter. This example is taken from the WWDC 21 session, Protect Mutable State with Swift Actors. I highly encourage you to watch it to get a deeper understanding of Swift actors. You can also read the actors section in Swift documentation about concurrency. So back in our example, we have a counter, which is a class. When we create an instance of counter and call the increment function, we might see 1 and 2 printed on the console, 2 and 1, 1 and 1, or 2 and 2. That is memory corruption because multiple tasks are trying to access the counter's value at the same time, and the result printed on the console can also vary a lot. To eliminate this potential bug, actors have been introduced in Swift 5.5. Actors are a new reference type and have similar capabilities to structs, enums, and classes. The only difference with actors is that they isolate their state from the rest of the program, meaning that their states are only accessible once a time. This prevents us from introducing data races or memory corruption into our application. Let's go back to our counter example. When we turn our counter class into an actor, we can access the increment function asynchronously by adding the await keyword in front. This lets the program know that the task can be suspended, which frees up CPU to let other tasks run at the same time. Also, it prevents data races and memory corruption because the counter is an actor, meaning that the value variable is only accessible once a time. Since we're running the code asynchronously, the first time that we call the increment function, we get 1, and the second time, we get 2, every time we run this code. So this solves our data race problem. Let's create a simple example of an actor in our project. Let's take a look at the profile card in account view. You can see that the description here that we're providing doesn't really mean much. If you remember, we called the company's catchphrase instead of the user's own description, so that catchphrase doesn't mean much. We'll create an actor and replace the catchphrase by the user's own description. So let's go to the user's model, and right below our user structure, we will create an actor. And we'll call this actor description. Inside of this actor, we will create one variable, which will be content, and it will be a string. You see that Xcode is now complaining and saying that the class description has no initializers. You might get confused here because description is in a class, but it's an actor. An actor is actually a wrapper on class, so it has the same capabilities as a class. It's just that an actor isolates its states from the rest of the program. So to fix this error, we will need to create an init function. So we'll do init, and we'll pass a content, which is a string. Then we'll simply assign the content variable that we pass to the init function to the content variable inside of this actor class. So we'll do self.content equals to the content variable that we pass to the init function. Next, we'll create an extension on description. Inside of this extension, we will create a function called update with new content. This function accepts a variable called new content, which is a string, so that we can update the content variable in our description actor. So we'll do self.content, which is the content variable from our description actor, will be equals to new content. So we're assigning a new string to the content variable. In profile card, we will create an instance of the description actor. So at the top here, we will do let description is equals to an instance of description. Remember that a description must have a content string. So for now, we will write, I am Leon Graham. On up here of this view, we will update the description. So let's scroll down to the bottom, and right after the full screen cover that we added in the last section, we will call the onAppear modifier. So onAppear of this profile card, we will call our description instance dot update with another string, which will say, I love design and code. However, we'll run into an error. It says that actor isolated instance method update can only be referenced from inside the actor. That means that the update function is only accessible synchronously inside of our actor. Outside of it, we need to access it asynchronously. Since the onAppear modifier doesn't work with asynchronous code, we need to replace it by the task modifier instead. We'll also need to add the await keyword in front of this function because we can only access it asynchronously if we're outside of our actor. Also, if we want to access the description content, we must access it asynchronously since we're outside of the actor. So right below this update function, we will add await description.content. And it says here that we're not using this property anywhere. So at the top of this view, we will create a private state and we'll call it user description, which will be a string, and we'll initialize it with an empty string to start with. Then we simply assign the user description to the description's content. And finally, in the body of the view, we'll update the user's company catchphrase by the user description state. And let's resume this preview here. And you can see that now it says, I love design and code. And in account view, instead of displaying the company's catchphrase of Leon Graham, it also says, I love design and code. Great, so we learned about actors and created a simple actor in our application. This allowed us to protect our mutable state, which was the content variable, from data races. In the next section, we'll go back to the home view and implement navigation between views. See you in the next section! Hi, Stephanie from Design Plus Code. Welcome to section number 17 of the SwiftUI Concurrency course. Right now, when we're tapping on a course card or a featured course card, nothing happens. In this section, we'll create a basic navigation going from the course card to a course view and then to a section view. We'll also pass dynamic data through each view so that the information displayed is accurate. Before anything else, we need to import files into our project. So go into the source files of this course, then navigate into the code folder and to the 17th section, navigating between views. We'll need all of these files when creating the course view and the section view. So let's drag and drop them into our components folder. So let's take a look at all of the files we just imported into our project. So we have a custom close button, which we'll use in course view and section view. We also have a course view cover, a course view subtitle, a course view title, a section row, a section view cover, as well as a section view title. Next, we'll need to create our course view. So under the views folder, I will right-click and create a new file. It will be a SwiftUI view, and we'll name this view course view. Our course view will take one argument. This argument will be a course. Don't forget to fix the preview by passing a course to the preview, which will be the course preview data that we added before. We'll also add an environment variable called presentation mode, so we can use the custom close button to dismiss this view. We'll split the course view into two small components. So let's remove the body here, and you can find the content of our body in the text content of this section. So you can see that we have a Z stack with our content variable below here. This content variable is a scroll view that contains our course cover view, and we pass a course to this course cover. Then we're creating a lazy V stack and iterating through all the sections of our course, and for each section, we're displaying a nice section row. We also have an H stack with a close button, and we're calling the presentation modes.wrapValue.dismiss so that we can dismiss this view. Now we'll need to implement the navigation from the home view to the course view. First, let's go to content view, and we'll wrap our home view in a navigation view so that we can use a navigation link. So we'll do navigation view and move the home view with its environment object inside of the navigation view. Next, we'll go to home view, and on our Z stack, we need to add the modifier navigation bar hidden and set it to true, because if not, it will add unwanted padding at the top of our home view. Then we'll go to the featured course list so that we can implement a navigation from this featured course card to the course view. So we'll go to the featured course list, and we only want the user to be able to navigate to the course view if we have the course data. So we'll only implement it for the first for each. So inside of the for each, we will add a navigation link, and the destination will be our course view that we just created. It requires a course, so we'll pass the course that we're iterating through. Then we'll simply move the featured course card inside of this navigation link as our label. Next, we'll do the same for course list. So let's go to course list. And the same here, we only want to allow navigation if we have the course data. So we'll simply add a navigation link in our first for each loop. Inside of the for each, we will add navigation link. The destination is the course view, and the course is the course that we're iterating through. Our label for the navigation link is the course card, so remember to add the course card inside of the closure. Now let's go to content view and test out this code. So let's click on play here, and you can see that we have all of our cards. Let's click on UI design for developers, And you can see that we are now on the course view with all the data that is dynamic and represents the card that we tapped on. Let's go to another course here, and you can see that the data is also dynamic here. However, you can see that our text on each of our card isn't aligned to the left. To fix this, let's go to course card, and on our title, we will add the modifier multi-text alignment, and the value will be leading. Let's do the same for our featured course card. So we'll add the modifier to our subtitle as well as our title. Let's resume our preview in content view to see if it fixed. So now you can see that everything is aligned to the left and it doesn't break our design. Next, we'll need to create our section view. So under the views folder, I will right click, create a new file. This SwiftUI view will be called section view. The section view will take two arguments. So it will take a course, which is of course type, as well as a section, which is of sections collection.section type. Now let's fix our preview. So we need to pass a course, which will be the course preview data. For the section, we will pass the sections that we have in our course preview data. So we'll do course preview data dot sections collection dot sections and get the first one. You can see that this is optional, so we can unwrap it with an exclamation mark. Next, we'll also add the environment variable in this view that is the presentation mode so that we can dismiss this view using our custom close button. The content of this view is similar to what we have in course view. You can find the entire code of this content in the text content of this section. So the body is really similar. We have a Z stack with the content and a close button. The content variable here is also a scroll view, and instead of having a course view cover, we have the section view cover. We also have a text that displays the content. So let's resume this preview, and you can see that it has all the data that we need for the section view. Right now, you'll see that we have a few words wrapped in asterisks. That is markdown. We'll learn how to format that markdown in the next section. Lastly, we'll need to add the navigation from the course view to the section view. So let's go to the course view file. Inside of the for each, we will add our navigation link. So navigation link, and the destination will be our section view. The section view requires a course and a section. So the course will be the course argument that we pass to this course view. And for the section, let's pause a bit here. So when we're iterating through the sections, we also added the dot indices to get each index of the section because we needed the index for the number on the left side of our section row. In order to have our section here, we simply need to call the course.sectionCollection.sections and then access the index. Finally, we simply need to add the section row as the label in our navigation link. Now, let's go to Content View and test out our navigation. Let's tap on the design system in Figma card. Now I'm in my course view and it displays dynamic data for the design system in Figma course. Next, let's go to the basic layout and techniques section. And you can see that we have our section view with dynamic data. You can see that it's hard to scroll down to the bottom, so let's go to section view and add some bottom padding of 100 to our section's content. So when we go back to this section, we can scroll down to the bottom. The same problem happens in our course view. So let's go to course view, and on our lazy V stack, we'll add some bottom padding of 100 as well. And now we don't have this problem anymore. Great, we now added the navigation from the course card to the course view and then to a section view. In the next section, using the new attributed string, we'll learn how to format our text using Markdown and add some styling to our strings. See you in the next section! Hi, Stephanie from Design Plus Code. Welcome to section number 18 of the SwiftUI Concurrency course. In this section, we'll take a look at the new attributed string. This new type of string allows us to easily format our text using Markdown. For example, you can see in the text content of this section that the Figma word is in bold. Also, using attribute container, we can also easily style our strings. For example, we can easily add colors to our date title here. Let's see how to do just that. But first, what is an attributed string? At WWDC 21, we saw many improvements in Foundation. The Foundation framework is, as the name says, the foundation on which Swift and SwiftUI was built on. It contains essential data types like numbers, strings, collections, date and times, and unit and measurements. It also contains a lot of basic functions that allow us to manipulate our data easily. You can read more about Foundation on this link here, and you can also find this link in the text content of this section. One of the improvements of Foundation at WWDC 21 was the introduction of attributed string. An attributed string lets you create a string with formatting and styling, and it's super easy to use. So we have a few examples in Apple's documentation here. First, we can see that we have a basic string, and then we're adding strongly emphasized to this string to make the text bold. We also have another attributed string here, and we're taking the link word and applying a URL to this link. Finally, we have an example that supports Markdown. In Markdown, when you write two asterisks at the beginning and at the end of your sentence, it makes the text bold. We can also add a link this way. So this will create our text in Markdown. For those of you who don't know, Markdown is an easy and lightweight language that allows us to format text. You can learn more about the syntax on markdownguide.org/basic syntax. This link is also available in the text content of this section. Here you can see how we create different levels of heading, and if we scroll down to the bottom, you can see that we have many ways to make a text bold, as well as making a text italic. In Contentful, when we added the sections to each course, we made sure that we added some markdown to the content. For example, we added some italic text here, as well as some bold text here. We can simply use this in our app now and learn how to use attributed string and markdown to format our text. Before Xcode 13, when we wanted to implement markdown in our application, we had to create a web view and use a parser, like Ink, that parses the entire markdown to convert into HTML code so that we can display that in a web view. This is a painful task that takes a long time to code. You can learn more about how this is done in the WK Web View section of the SwiftUI Advanced Handbook. Luckily, now that text supports Markdown, we can simply convert our Markdown string into an attributed string, and the text will automatically be formatted for us. Right now, the content of our section is a plain string. That's why when we're displaying it in a text, we see the actual text with asterisks around the just enough words instead of italic text. In other words, we see the markdown and not the formatted text. To fix this, we need to convert that string into an attributed string. First, at the top, we will create a private state, which will be an attributed string. So the type will be attributed string, and it will be equals to an empty string to start with. Then we'll need to convert this text on appear of the view. So we'll add the onAppear modifier here. On appear of this view, we will create an instance of attributed string from Markdown. And the Markdown that we pass to this attributed string will be the section.content string. You can see that we have an error here that says that the call can throw, because when creating an attributed string, it might fail. So we need to add the try keyword in front. If you remember in the previous sections, when we added a try, we had to catch any error that might be thrown. So we'll need to wrap this in a do catch statement. And in the catch statement, we will print our error. Couldn't parse, and then print the actual error. Then we have a warning that says that the result of attributed string initializer is unused. So let's save this in the attributed string variable that we created at the top. And finally, we will replace the section.content in our text by the attributed string. Let's resume the preview to see if it works. So you can see that the asterisks surrounding the just enough words are now gone, and we see italic text here instead. So that's how we convert Markdown into an attributed string so that we can display formatted text in SwiftUI using text. Now let's see how we can style our strings another way, using attribute container. We'll learn how we can add a foreground color to our title with attributed string. Let's go to Home View. Instead of passing a plain string to the date title, we'll pass an attributed string that we'll create within this view. So just before the body variable, we'll create an attributed string variable. So var attributed string, which will be of attributed string type, and we'll add a closure here. So within this closure, we will create this attributed string. Inside of these curly brackets, we will create a subject variable. It will be equals to an attributed string. And inside of the parentheses, we'll call the course view model dot featured subject dot raw value. So this will create an attributed string from the featured subject that we have in our course view model. Since we only want to add styling to the featured subject and not to the learn word, we're creating an attributed string only for the subject. We also need to add the raw value here because we want the actual string of the featured subject. Next, right below the subject, we will create a container. This container will be an attribute container and we'll initialize it. An attribute container is a container in which we add attributes. And these attributes are styling that we're adding to the string. For example, we can add a foreground color or underline the text with attribute container. So back in Xcode, we will call the container and set its foreground color to purple for now. In order to apply the styling to the subject, we need to call the merge attribute function. So we'll do subject.merge attributes, and the attributes are what we added to the container, which is the foreground color. Finally, we will return the entire title. So we'll return the learn word with a space right after, plus the subject variable. So in the date title, instead of passing this string here, we will replace it with the attributed string that we just created. So let's remove this and add attributed string. Now we have an error. It says that it cannot convert value of type attributed string to expected argument type string. Let's right-click and jump to definition to go to our date title. You can see here that our title should be of string type. So let's simply update this to attributed string. So this will silence the error. However, in date title, the preview still has a plain title in all black. We can add some color to the subject by creating an attributed string only for the preview. So right before our preview, we will add static var attributed string will be of attributed string type. Then we can go in our home view and copy all the code that we just added and paste it in our attributed string for the preview. Instead of taking the featured subject from our course view model, we will pass a string that says SwiftUI. The last thing to do is simply to pass the attributed string to our preview. And you can see that we have learn SwiftUI and SwiftUI is now purple. Let's go back to home view, and instead of always displaying the subject in purple, we can add a custom color to our title. Let's say we want the foreground color of the subject to be the same as the background of the first featured course card. So in home view, right after our container, we will initialize a color using the hex extension that we created before. So we'll do let color will be equals to color.init, and we pass a hex value, which will be the course view model dot featured courses. We take the first one dot colors and we take the first color. Remember that the color is optional, so we need to add an exclamation mark to silence the error that says that it's an optional. Instead of setting the foreground color to purple, we'll set it to the color variable that we just created here. If you try to build your application, you'll run into a crash because the featured courses array is empty on first load, so the index is out of range. To fix this, we need to make sure that the featured courses array contains more than one item before applying the custom foreground color. So we'll wrap this in an if statement. So if CourseViewModel.FeaturedCourses.count is higher than 0, then we will move the color and setting the custom color inside of this. Else, we will call the container.foregroundColor and set it to purple by default. Now let's go to content view and test out this code. Remember to press on play here so that you can see the result. You can see that now we have learn design and the design word is in the same color as our first card here. In this section, we learn how to use the new attributed string to format our strings different ways. In the next section, we'll learn how to implement localization in our application's content in Contentful and query the content in the device preferred language. See you in the next section. Hi, Stephanie from Design Plus Code. Welcome to section number 19 of the SwiftUI Concurrency course. If you remember, in the section Setting up Contentful, when creating the content model, we made sure to check the box Enable localization of this field for all fields that needed translation. This comes in handy for us now because we can make our application's content adaptive to the preferred language of the user. But first, what is localization? Localization means adapting your application's language to the preferred language of your user. For example, here we have the content translated in French. This makes the application more accessible as not everyone knows or is comfortable in English. Also, they might prefer to read the content in their own language instead of English. We can easily add this feature in Contentful so that all of our content can be localized. Before we set up localization, you need to make sure that the fields you created in your content model in Contentful have localizations enabled, especially for the fields that need translation. To verify, go into your content model, then click on either course or section. For the course, you need to make sure that the title has localization enabled, as well as the subtitle. For the section, we need to localize the title, the subtitle, and the content, so all three fields should have localization checked. If it hasn't been checked, check them, but please note that you might need to re-download the schema.json file using the Apollo CLI. Go back to the Apollo GraphQL section of this course and follow the steps to re-download the schema from the terminal. Next, we'll need to add a locale. So click on Settings, then under the Environment Settings, we will click on Locales. In here, you can see that we already have a default locale, which is English United States. So click on the Add Locale blue button on the right side, and you will select the language that you want to support in your application. For me, I want to add French Canada, and the fallback will be English United States. That means that if the French translation isn't available, the English content will be used instead. Then let's click on Save. Next, let's navigate to the Content tab. Click on any course that you added. Then on the right side here, under Translation, we will click on Change and check the other locale that you added as well. Then click on Save. You will see that they will add a field for each field that we enable localization. So we simply need to translate each of these titles in the language that we added. I'll simply copy the English title and then paste it in Google Translate, or you can use another tool that you want, and copy the text and paste it back in the French field. You need to do the same for the subtitle, as well as each section that we added to Contentful. Don't forget to also do it for all the other courses that you have in Contentful, so that localization works in your application. Once you translated everything, make sure that all the courses are published, as well as all the sections within each course. Now that all the required data in French has been added to Contentful, we'll need to update the query. We'll use the GraphQL Playground to test out our queries. You can find the link to access the GraphQL Playground in the text content of this section. Remember to replace the Your Space ID by Your Space ID and Your Token by Your Content Preview API token. So we'll go into Xcode and open our course query. We'll copy this query and paste it in our GraphQL Playground. Let's click on Play. You can see that we have all the data in English. It's easy to add a locale. Right after our course collection, we will add parentheses and we'll provide the locale, which is a string. The string will be French Canada. If you don't know what is the symbol of the language that you added, you can go back to Contentful, and under translation here, you can see the symbol of your language. So now that we added the French Canadian locale, let's click on Play. And you can see that all of our content is now in French. However, we don't necessarily want to hard-code the locale in our course query. We want the query to look at the preferred language of the user's device and make the query accordingly. Therefore, we need to pass a variable to the query. So we'll add parentheses right after the query course and add a variable. In GraphQL, when you pass a variable, you need to add a $sign in front, then provide the name of your variable, and add a colon, then the type of data that you want to pass. In this case, we want to pass a string. Instead of hard-coding a string that says French Canadian, we will pass the locale. So we'll do $sign and locale. In GraphQL Playground, we can expand the query variables at the bottom here. We can simply drag it up and then provide an object. This object will have a locale, and this locale will be the locale that you want to pass to this query. So we want to pass the French Canadian. Now let's click on play, and you can see that all the data that we got is in French. So let's copy this query and paste it in our Xcode project. Since we updated our query, we need to regenerate the api.swift file. So click on your project, and then on your target, build phases, and under the generate Apollo GraphQL API script, uncheck the for install builds only. Then we will build our application. This will regenerate the api.swift file to reflect the changes in our query. Once you build your application, you might run into an error, and it says missing argument for parameter locale in call. If you go to your api.swift file, you can see that we have locale in our course query, so it updated the api.swift file. If you don't have the locale in your API file, make sure to drag and drop it in your project again. We simply need to fix this error here. Let's click on Fixed, and you can see that it requires a string, which is the locale. So let's provide the French Canadian locale. If you run into an error other than a missing argument for locale, you'll need to re-download your schema file from Contentful and drag and drop it into your Xcode project again. Now, let's rebuild our application. And you can see that all of our content is in French now. However, if we kill the app and come back to the application, you can see that our content is still in French. What if we want our content to reflect the preferred language that the user set on their device? First, let's go to our settings. Under General and Language and Region, we will change the order of the preferred language. So since I added French Canadian in Contentful as my other locale, I will drag the French and place it in first place. The simulator will need to restart in order to apply these settings. So let's click on Continue. The simulator has restarted, and you can see that the simulator is now in French. Let's go back to Xcode. And on the first line of the continuation closure, we'll add locale.preferred languages. You can see that it returns an array of strings. So we will want to get the first one, which is the first one that we move to the top of the list. Next, we'll save this in a let preferred language variable. Now let's print this preferred language to see how it looks like. So let's build our application. And you can see in the console that we have preferred language French-CA. The first two letters is the language, and what is after the dash is the region of the user. So in this case, it's Canada. Since we only support US English and Canada French in our application, we need to add an if statement so that the preferred language always falls into either French Canadian or English US. So let's remove the print here, and we'll add another variable called locale, which will be equals to a ternary operator. So we'll check if the preferred language contains the FR string. If it contains the FR string, then we will fall back to French Canadian, else we will fall back to English US. We need to do this because if we don't add the locale in Contentful, it will crash our application saying that we don't have this locale added to Contentful. Finally, we simply need to pass the local variable in our course query. Instead of hard-coding the French-Canadian locale, we will pass the locale variable that we created on line 24. Now, let's build our application again. So right now, my simulator is in French, and you can see that all the data here that we have is in French. Even if I go into a section, you can see that the content here is in French. Let's test our application in another language. So let's change the simulator preferred language to English instead. And then let's go into our application, and you can see that the language here is now in English. Let's test this application with one last language. So we will add another language, and you can select any language that you want. In my case, I will select Spanish. And you can see that our content is now still in English, because if the preferred language of the user is in French or English, we default it to English. Nice! The localization for the content works as expected in our application. We learned how to set up localization in Contentful, get the user's preferred language on their device, and pass the corresponding locale to our GraphQL query. In the last section, we'll see how we can make our application even more accessible using VoiceOver and accessibility labels. Hi, Stephanie from Design Plus Code. Welcome to this final section of the SwiftUI Concurrency course. In this section, we'll cover a topic that is very important for all applications nowadays: accessibility. In Xcode 13, adding accessibility to our application has never been easier. We'll learn how to use the new accessibility section in Xcode right panel and how to add accessibility labels, hints, and traits to make our app more accessible for VoiceOver users. Apple provides a lot of vision accessibility features. You can explore them all on this page here, which is also available in the text content of this section. VoiceOver, one of the accessibility features and one of the most popular ones, is a screen reader for visually impaired users. When activating it, it describes to the user the content on screen and reads the text. In Xcode 13, a new section has been added to the Write Modifiers panel, the accessibility section. This lets developers code apps that are more accessible than ever, since we can just take a look at the preview tool to make sure that the elements in the view are correctly labeled for VoiceOver to read. Let's test the accessibility of our application with VoiceOver. First, connect your iOS device to your Mac and build and run your application. So I will select my iPhone and build the application on my iPhone. You need to make sure to test on an iOS device because VoiceOver doesn't work on the simulator. You also need to make sure that your iOS device is running on iOS 15, since we targeted our app to only iOS 15 devices. To check if you have iOS 15, go into your device settings and scroll down to General. In here, click on About, and you will see the software version here. So I have 15.0. Make sure that your software version is also 15.0 or higher. You can download and install iOS 15 by going to Apple's downloads page on your device and downloading the iOS 15 Beta 2 on your device. Once everything is ready, we will go into our device settings. Then we will scroll down and click on Accessibility. You can see the first option is VoiceOver, so let's click on that and we'll enable it by turning the switch on. The VoiceOver cursor, which is the black outline surrounding the VoiceOver row, will appear on your screen. It will read each element that the cursor highlights. If it's your first time using VoiceOver, it might be hard to understand the gestures to navigate to the next element or read a certain item. You can learn about the VoiceOver gestures at this link here, which is also available in the text content of this section. The basic gestures are to tap or touch an item to select and speak an item, swipe right to select the next element, swipe left to select the previous element. To scroll up and down a page, use 3 fingers. To activate an item, you simply need to double tap with 1 finger. Please note that VoiceOver currently doesn't work for me because I'm recording my iPhone screen at the same time. But it should work for you if you simply build your application on your device and you're not recording your screen. To improve the accessibility of our application, we can add or update accessibility labels and hints. So accessibility labels are, as the name says, labels that describe one element the user selected. The label should be a short string and descriptive of the element. You can see the example that Apple gives here. We have a save button and the label of this button, instead of being save button, should only be save. It should simply identify the accessibility element, but not the type of the control or the view. Accessibility hints are taking accessibility a step further by letting the user know what happens once the action or functionality of the UI element is completed. For example, what happens when the user taps on a course card? We go into the course view. Let's go to our application. Let's select the profile icon on the top right corner of the home view. VoiceOver says Account Image. However, that doesn't really reflect what this button does. So let's update this to better reflect what it does. In Xcode, let's go into our profile icon component. In the last section, remember that under our Generate Apollo GraphQL API script, we uncheck the for install builds only so that we can regenerate the API file. Remember to check it back so that the previews don't always pause. So in our profile icon, build your application for the preview. And on the top right corner here, you can see this icon to hide or show the inspectors. So click on that and select the last one, the attributes inspector, and you will see here that we have an accessibility section. So we'll need to update the label of our profile icon. So let's click on the little edit icon on the right side so that it adds an accessibility label to our code here. And instead of saying label, we will add sign in to our profile icon. Next, we'll also add an accessibility hint. So let's click on the edit icon here. And instead of hint, we will say open sign-in model. So this is what happens when the user taps on our profile icon. Since VoiceOver says that this profile icon is account image, we also want to let the user know that it's also a button that they can tap on. So under the traits here, we will check the button box. This will add the accessibility add traits modifier and add the is button value. So I'll simply move this to the bottom here so that all the accessibility modifiers are together. Now, when testing our application, VoiceOver will say that this is a sign-in button and the action is open sign-in model. Now, let's test our application with VoiceOver when going into a course view. So we'll select a card and double tap on it to go into the course view. If you listen closely when you're testing on your side, you will hear that VoiceOver will read the back button here that is selected, left button. We need to update the accessibility label and hint so that it reflects better the use case here. So let's go into our course view, and on our close button here, we will add an accessibility label. Instead of label, it will be back, and we'll also add an accessibility hint so that the user knows what happens when they tap on this button. We'll write go back. Now, VoiceOver will read this button as back instead of left. Moreover, we're adding the hint as go back so the user knows that this button goes back to the previous view. Since we have a similar code for our section view, we'll go to section view to add the same modifiers. So on our close button, we will add these two same accessibility modifiers. So these are a few simple examples of how we can update the accessibility label and accessibility hint to make our application more accessible with VoiceOver. We can't talk about VoiceOver if we don't talk about rotors. The VoiceOver rotor is a shortcut that lets user adjust VoiceOver and skim quickly through a view. For example, a user can set their rotor to headings so that VoiceOver only reads the headings on the screen. In order to access the VoiceOver rotor, when VoiceOver is enabled on your iOS device, use two fingers and rotate your fingers together on the screen, as if you're turning a dial. The rotor will appear, and you can select a rotor option so that VoiceOver can read certain elements on your screen and not everything on it. For example, let's set it to headings, and then we'll open our application. If we swipe up and down quickly, VoiceOver should only read all the headings in our application and not the rest. However, we're running into an issue here. Whether we swipe up or down, VoiceOver will say heading not found. Let's go to Xcode, and we can fix this with a modifier called accessibility add traits. In this case, this modifier lets us mark a certain text as a heading so that VoiceOver recognizes it as a heading and reads it to the user. Let's go to Home View. We'll add this modifier to the date title. So let's go into the date title component, and we'll add the modifier accessibility add traits. And on the left side, you can check the header here so that it automatically adds the is header value, or you can simply also type it. Let's go back to Home View, and we'll do the same for the all courses here. So we will add the accessibility add traits modifier, and inside of this, we will add the header option. Now, let's go into a course. So we'll select a card and then double tap on it. If we swipe up and down, VoiceOver will say the same thing, heading not found. So let's add the accessibility add traits modifier to the title in the course view cover. Let's open the course view cover file. On the course view title, we will add the accessibility add traits. It will be an array, and we will check the header option. Let's do the same for our section view cover. So let's go to section view cover, and we will add the accessibility add traits modifier here. So now that we added all of these modifiers, when we will test our application and swipe up and down, You will hear VoiceOver read only the headers in our views. Accessibility is a complex topic and we can't cover everything in one single section. And of course, we can make the application we built together even more accessible by auditing it more thoroughly and adding more accessibility labels and modifiers to our views. When you're done adding the accessibility modifiers and testing accessibility on your device, remember to go back into your settings, then scroll down to Accessibility, VoiceOver, and turn off VoiceOver if you don't wish VoiceOver to always read the content on your screen. If you wish to learn more about accessibility, Apple provides lots of resources. Here are some suggested resources to learn more about the subject. The SwiftUI Accessibility Beyond the Basics WWDC 21 session, the accessibility documentation on Apple developers' website, or the supporting VoiceOver in your app article on Apple developers' website. You can find all of these links in the text content of this section. Congratulations! You completed the SwiftUI Concurrency course. To wrap up, we learned in this course many new features that were introduced at WWDC 21, including async await functions, pull down to refresh, swipe actions, and search. We also learned how to query data from Contentful using Apollo GraphQL and present them in our application. Moreover, we covered accessibility by adding localization in Contentful and adding accessibility labels to improve the VoiceOver experience in our application. I hope that you learned a lot in this course and that you apply all of these new concepts in future SwiftUI apps that you'll build. I can't wait to see what you'll build.